nucleophilicity between the I- and the Br- anions. Generally speaking, iodide anions are stronger nucleophiles, especially in situations where there might be something polar and protic present, right? Because iodide anions are bigger and more polarizable, better able to distort their electron density to reach out and form a new bond. Right? So if I were to guess, and I haven't looked up data on this yet, but if I were to guess at what I would find if I were to look up data on a reaction like this, I would be willing to bet that if I used HI, then I would see more of these products. Whereas if I used HBr, I might see more of these products. Make sense? Itty or frowning? Make sense? Then of course, if you used an excess of your HX, then this alcohol would go on to react with it. So if you use more than 2 molar equivalents, then your alcohol that you form there would get protonated. And in this case, you would not have the likelihood of this doing any kind of SN2 attack, because that's too sterically hindered with that alkyl halide. So therefore, you would expect in this case for water to get lost. Form the tertiary cation that your X minus would add to. So in the end, you would have that plus this. That you formed before. Similarly over here, if you used another molar equivalent, then that would get protonated. Then your X minus would now have to do the SN2 attack. So you'd make this, but you had that around from before. Right? So the idea is that after 2 molar equivalents, you can't tell the difference. You can't tell what mechanism it went through. But if you could somehow stop the reaction after just adding 1 molar equivalent of HX, then you might see an indication of what mechanism was followed or what combination of mechanisms might be followed. And then since there was a question about this, if we had this kind of an alcohol, oh, we're talking about ethers, that kind of a phenyl ether, step would be the same here. But then that kind of oxonium ion is completely limited in what it can do. So you could not break this bond to make a phenylcation, because we're going to learn shortly why that's really unstable, right, or unfavorable. And so there would be no choice but for your anion to attack the carbon and kick this out, so that your product mixture would only contain that alcohol and that iodide. The other thing about this is that although the iodide is a good nucleophile, you have to remember what this is. It's a benzene ring which has this circulating cloud of pi electrons above and below the plane of the ring. So therefore, if a nucleophile like I- were to approach to try to get to the back of this orbital to kick that out as a leaving group, what it would encounter first would be that circulating system of pi electrons. So things on benzene rings do not undergo SN2 types of substitution. They may undergo other kinds of substitution reactions, but they're not SN2. It's not a simple matter for the nucleophile to attack and kick out the nucleophile. So therefore, since that can't happen, the only option would be to attack here and kick out phenol as a lead. Any questions on that stuff? Going once, going twice. Let's say I took these two things and I put them together with some NaH, or I took this thing and put it together with some NaH and then mixed it up with this, right? We'd expect to do what? Get rid of this proton. And then do what? So we get some kind of ether, in this case